One of the most interesting and important applications that we have for right triangle trigonometry is the use of being able to find heights or distances below us if we're looking out at a horizon. We use something called angle of elevation and angle of depression to express that kind of idea right here. When we talk about angle of elevation, pretend that you're looking out across the horizon, just straight out horizontally ahead of you. The angle that we have to look up to find an object is called the angle of elevation. So our angle of elevation in this particular illustration, looking up at the sun, is the angle that we would look up from the horizon to the height of that sun, whatever that particular angle is. An angle of depression, as Clem looks down over here at the at Donkey, we see that this is our angle of depression. That doesn't have anything to deal with how we feel. It just tells us what angle we're looking down at as compared to the horizon to tell us the angle of depression. So looking down, we consider that an angle of depression. Looking up, we consider that the angle of elevation. Well, here's an example using this angle of elevation idea. Let's say from a point 50 feet in front of a church, the angle of elevation to the base of the steeple at the top of the steeple are 35 degrees and 47 degrees 40 minutes respectively, and we want to find the height of the steeple. Well, it will help us to draw out this situation. So let's put our little guy over here 50 feet from the front of the church. And 50 feet in front of the church, this guy stands right here. So we'll put him out here about 50 feet away from the front entrance. 50 feet. Okay. And looking up at its angle of elevation, and we'll just consider this ground here. We're not going to include the height of the guy, just for the purposes of our argument right here. Let's say our angle of elevation to the bottom, from the base of the steeple, right here is 35 degrees. And then looking a bit further up, we see the top of the steeple up here, and it's at an angle of elevation of 47 degrees and 40 minutes. All right. So what could we say right here? Well, if we wanted to find the height of the steeple right here, let's call this distance right here, the total distance in blue to the top of the steeple. Let's call that height x2, right? That's the highest height we're going to get. But then we have this other height down here, which is from the base of where the man is standing, 50 feet above that. We'll call that x2. Okay. Now, really, he could be standing there looking at this church right here. Whether we're looking at it from his eye height or from the ground height is not going to make much difference as far as our calculation is concerned. And the reason why is that if we look at the ratio right here, we have a ratio of opposite side. I'm going to call that height x1, not x2, because I've already used x2. Here's x1 right here. We say that the height x1 divided by 50 feet would be the tangent of that 35 degrees. So tangent of 35 degrees would equal x1 divided by 50. So if we want to find that height, what we're going to do is we're going to take x1 to be equal to 50 times the tangent of the 35 degree angle. All right. I worked this one out. I took my tangent of 35 degrees, multiplied it by 50, and I found that my height here was 35.01 feet. All right, so far so good. How about the other one? Well, the other height, x2, is found by taking the tangent of our 47 degree 40 minute angle and say, well, that's the height x2 divided by the distance 50. So if we want to find x2, we're going to have to take 50 and multiply it by the tangent of that 47 degree 40-minute angle. Well, most of our calculators are a little bit more difficult to work. Some calculators will work in degrees, minutes, and seconds, but let's go ahead and convert that. If I wanted to find 47 degrees and 40 minutes in terms of just degrees as a decimal, what I'm going to do is I'm going to say, well, this is the same thing as 47 plus 40 sixtieths of a degree. And, well, 40 over 60 reduces to 4/6, which reduces to 2/3. And as a fraction, that's the same thing as saying 0.6 repeating. So I'm going to round this out, and let's go to the nearest hundred. So let's call this 47.67 degrees for the purposes of our calculation. So x2 will equal 50 times the tangent of our 47.67 degree angle. So working this out, I find that x2 is actually equal to 54.89 feet. And so if I wanted to actually find the height of our tower, the height is going to be found by taking the difference between these two distances, so x2 minus x1. And so if we take 54.89 feet and we subtract from it our 35.01 feet, we're going to find our height is 19.88 feet. So just a little shy of 20 feet for the height of our steeple here in the drawing.